I didn't know there was a disco going on here. Oh well, I'm not going to question it. I just find it to be pretty crazy that these two parts are essentially changing colors just simultaneously at the same time, especially when it's looping through so many different parts at once. You wouldn't really be able to do this inside of a standard script unless there were multiple tasks running at the same time. I think what I just explained pretty much sums up what I'm going to be talking about in this episode, which is kind of a part 2 to my task functions video that I made a while ago. Having the ability to do multiple tasks in the same script is something very powerful. That's pretty much with the use of coroutines, and it's important to understand that there is a difference between coroutines and task functions and why I made them in 2 separate videos. So this will pretty much be a continuation from my task functions video into another multitasking system that is honestly better than task functions depending on how you use it. And so that's what I'm going to be showing you how to do inside of this episode. Alright, let's think about this for a minute. You seem to really like my example previously with task functions when I created all these tasks represented as parts. So I pretty much brought it back, but this time with coroutines. So what's the whole idea of coroutines? Well, pretty much, it's kind of similar to task functions in a way how we want to create multiple threads to be able to run multiple tasks at the same time using the same script so that we can basically do a whole bunch of stuff simultaneously without having to wait for whatever is previously in the script to then run whatever else is underneath it. So we basically have these tasks here, and we have coroutine functions that relate to what we're going to be discussing about inside of this episode. So let's say we have task 1 and task 2. We want to be able to run these 2 tasks at the same time, but how do we do that? Well, what we would do is instead of writing all of this inside of one thread, we can create a new thread and make it wrapped around inside of this second task we want to do. And this is a concept called multi-threading. So we would basically do that by creating a new coroutine thread and just slap this inside of task 2 so that we can run both of these at the same time. But just creating the task is not going to be enough. We have to actually execute the task as well by using resume to then actually execute the coroutine task that we created inside of our script so we can run task 1 and task 2 at the same time. Now, so far, this looks pretty similar to task functions, but there is one key difference between task functions and coroutines is that we have the power to pause these multi-threading tasks using a function called yield, which basically says during execution of our coroutine, we can literally pause the task in order to do other things outside of this multi-thread first before going back into this task to do whatever we want the task to do. So basically, if we yield this task, then we're not resuming this task anymore. And in order to make this task run again, we would just simply use resume, get rid of the yield, and then the task would be running just like normal. And so if at any point we don't need to run the complete version of this task anymore, or just things in the script have changed, then we can just simply close the coroutine task and create a new one. So it basically just gets rid of our coroutine task that we had previously. And so this is just a couple methods used for coroutines. Yielding is probably the biggest game changer for these multi-threaded tasks inside of your scripts. And that's what we're going to be doing inside of this episode. It serves as task functions with more control over your multi-threading processes. So I hope that made sense to you. And now let's get to implementing. Now that we understand it, let's use coroutines to create multiple threads so that they can all run at the same time using the same script. So on the right side next to server script service, we're going to hit the plus sign and we're going to create a new script. Before we start writing, here's what I want you to understand about coroutines is that when you create a new coroutine, it should be placed inside of a variable. And when we check to see what this coroutine actually is, it's basically a thread object that has different functions that we're going to be using inside of this episode. So let's create a variable. And this one is going to represent our second task. So in double dashes, we're going to make a comment by saying task 2. And then down here, we're going to create a coroutine for the second task. So we're going to make a variable by saying local, and we're going to call this task 2 equals coroutine.create. So this is pretty much the method we're going to use in order to create a new coroutine and set it equal to our second task. So in this coroutine, we're going to make a function by creating one inside of these parentheses. So we're going to say function, open parentheses, close parentheses, hit enter. So this is pretty much the general structure of creating a new coroutine and saying it equal to a variable. If we try and print the new coroutine that we just created, so let's drop 2 lines and then say print task2. If we go into the game, hit test and hit run, and we look at the output, we can see what kind of variable our task2 is. So it pretty much printed out a thread object, and all these numbers basically mean the location in memory that this new object was created in. This part does not really matter too much, but what does matter is that our coroutine that we created is basically a thread object that has functions that can be used to manipulate when we run these coroutine tasks. So let's hit stop and let's go back to our script. So now that we know that when using coroutine.create, we basically create a new thread object and we set that equal to our task2 variable. So let's delete this print statement here, and now we can write stuff inside of this new coroutine that we created, this new coroutine task that we created. So we can just make a print statement here by saying print coroutine task, and then we can drop 2 lines down here. So there we go. We've basically created our first coroutine, but if we try and run the game, this task isn't actually going to run because we tied it into a variable. So now we have to execute task2. And the way we're going to do that is by using a function from coroutine called resume. Because by default, when we create a coroutine, it's not going to run on its own. We basically have to do that manually. So what we're going to do down here is basically write coroutine.resume, and then in parentheses, we're going to put in our coroutine that we created, which is task2. So now if we hit run, we should see our coroutine executing. So down here, it says coroutine task because we created our coroutine and then we used the coroutine.resume function and we passed in our task2 coroutine to actually run it. There's different states to these coroutines, which I will explain later on in this episode, but that's just something for you to know about for now. Now, it might seem kind of unusual that we're creating a task wrapped inside of a variable and then we're just calling coroutine resume on that coroutine that we created. It seems like a weird structure. However, there is an easier way to write this, and this is going to use wrapper functions. So the way it's going to look is we're going to first create a task, and then we're just going to call that task after we've created it. Let's make a blocked comment statement by selecting up here, and we're going to put the 2 dashes, but also put in 2 open hard brackets. And then at the end here, we're going to put in the closed end brackets by putting 2 of them here. So now let's drop 2 lines. And what we'll do is we'll create a variable, and then we will wrap this around inside of a coroutine.wrap function. So the way it's going to look is we're going to first create a variable, which is local task2 equals coroutine.wrap. And then inside of here, we're going to create another function, open parentheses, close parentheses, hit enter. And let's make our same print statement. So we're going to say coroutine task. And so right now, this looks pretty similar to our first coroutine task. But what we can just say down here is task2, and then put in the open and close parentheses. And this is basically all you need to do. So it's a little more simplified than what we had up here, but both of them generally do the same exact thing. So if we hit run, then we should see the exact same result, just like in the first example. So it just printed coroutine task after we created a wrapper function, called that function just by its name with the open and close parentheses. So that's another way of writing it. And if you want to further simplify this even more, what you can do is not even have a variable here, just like get rid of the task2 variable and get rid of this down here as well. And we can simply just put in 2 parentheses right at the end. So this is all you need to say. It's just basically 3 lines that creates the coroutine.wrap function, and then it prints whatever's down here, and then we end it with the open and close parentheses. So this is also another really simple way of writing these coroutine threads. However, the issue with writing it like this is that we're not able to retrieve this coroutine once we're done executing it because we didn't wrap this inside of a variable. So I do want you to be cautious if you do write it this way. There's also one more way I can think of when writing these wrapper functions inside of these coroutines, and that's by wrapping a function inside of a local variable and then just using coroutine.wrap surrounded by that variable and just call that within one line. So we're going to make a function that's wrapped inside of a variable. So we'll say local my function equals function, open parentheses, close parentheses, enter. And we could just put in some random stuff in here, print function. And then down here, what we're gonna do is say coroutine.wrap. And then inside of here, we're going to put in our function. We're gonna say my function, and then open parentheses, close parentheses, just like this. This is another really easy way to write a coroutine. And of course, this isn't the only way you can write a function signature. You can also just say local function, my function, open parentheses, close parentheses. And this is also another way of doing it too. So I just wanted to throw these two examples out there as well. There's multiple ways to do this stuff, and it's just a matter of understanding these different structures of creating these coroutines. All right, and since we are writing functions inside of these coroutines, it actually is possible to pass in function arguments, and I'm going to show you this by using our last example. So let's uncomment our previous example, and let's comment our new example because we will hopefully come back to this as reference. What we can do here inside of our function, inside of our function declaration, is add extra parameters in here. We can put whatever arguments we want in here. Let's make a system where we pass in two numbers and we're going to print the sum of those two numbers. So let's make the first argument num1 for number 1, and then comma num2 for number 2. And then down here, what we're going to do is print num1 plus num2. And so now, the way we pass in arguments into this coroutine function is by going to where we call this coroutine thread, and we just simply put in the thread itself, and then we space it with a comma with whatever other arguments we have after that. So this one is going to be our number 1, and then we put another comma here, and this one's going to be number 2. So once again, when we call coroutine.resume, we're first going to pass in our coroutine thread, and then everything after that is going to be the function arguments. Our result, so when we load into the game, it should say 4 because 2 plus 2 is 4, and then it's going to say coroutine task. So let's run the script and see our output. So yeah, it printed out 4, and it also printed out coroutine task like expected. Now let's try running multiple tasks at the same time. So you know how 2 loops go, right? If it's 2 while loops, for instance, let me just write some comments here so I can get you to understand this analogy. So if we have 2 while loops, while, true, do, and then it's going to end with an end here, and then we have another while true do statement and end it right here. Basically what this is saying is that we're going to constantly go through this loop over and over again repeatedly, and it's never going to run this while loop because it needs to finish this while loop before going into this one. But what if this while loop consistently runs throughout the entire game without ever going to whatever's underneath here? If we want to be able to run 2 loops at the same time, or multiple tasks in this case, we would use coroutines. So let's delete everything that's inside of the script as of right now. So let's delete all this. And what we're going to do is create 2 loops that'll run simultaneously at the same time while the game is running in order for this to work. So what we can do is create one coroutine for one of our loops and then just call the other one normally. For our first one, we're going to say local loop 1 equals coroutine.create, open parentheses, close parentheses, function, open parentheses, close parentheses, enter. Let's create a while loop. Let's say while true do. Let's print task1, and then we're going to put in a task.wait statement down here so that it doesn't just repeatedly call this print statement. Let's put in a wait statement of 0.01. And what we'll do is execute this coroutine by saying coroutine.resume, open parentheses, close parentheses, and put in loop 1. So this is our first loop. When we run the game, then what we should see is task 1 that's constantly being printed into the output, as you can see right here. But what we want to do is run two while loops at the same time. So after our coroutine resume, we're basically going to do the exact same thing we did here, but instead, it's going to be within the main script, not inside of a thread. So we're going to say while true do, enter. Then we're going to make a print statement by saying task2, and then down here, we're going to write another task.wait statement with 0.01 as our wait counter. So now if we go into the game, we should see both of these while true do statements running at the exact same time, back to back. So inside of the output, we can sometimes see task 1 printing before task 2, and then task 2 printing before task 1, but generally speaking, they are running at the exact same time during execution. So that's one of the benefits of using coroutines, is by being able to run multiple tasks at the same time. Now, you remember how I mentioned that when we create the coroutine, that doesn't automatically mean that it's executing, because what's happening is that when we create a thread object using coroutine.create, we have to manually execute it ourselves because these coroutines have different states of operation, if that makes sense. So when we create our coroutine, the state of the coroutine is basically one that's not executing, so it hasn't started yet. And these are called coroutine states. So there are 3 coroutine states we should know about. If I drop a couple lines down here and just write this down inside of my script right here, well, there's actually technically 4, but there's only 3 that we really need to know about for this episode. The 4th one, you can do more research if you decide to go more deeper into these coroutines, but these are the 3 that we need to know about. The first one is suspended, the second is running, and then the third one is dead. And basically what's happening is that when we first create a coroutine, it's automatically going to be in the suspended state, meaning that it's not currently running, but that also doesn't mean it's dead. It just means it's at a pause. Running means that obviously the coroutine is currently running or currently executing as we speak when we check the status. And then dead pretty much just means that the coroutine is either over or it got canceled, and this coroutine can no longer be used afterwards. And we can check these statuses by using a function simply called coroutine.status. So we can do that by dropping a line here. Right before calling coroutine.resume, we can write a print statement over here and just simply call our coroutine's status by saying coroutine.status. And then inside of these parentheses, we're going to pass in our coroutine, loop 1. And let's do the same thing after our coroutine.resume as well. So we can check to see the status of our coroutine in real time. What we're going to do is we're going to comment out these while true do statements so that we can see the effect of these print statements that we're trying to look for. So now let's hit run and see what happens. So as you can see, before our coroutine executed, our status of our loop 1 coroutine is suspended because nothing ran yet, or it's currently paused. And then after our coroutine executed, we checked the status and it's now dead, meaning that we can no longer run it and we're just gonna have to create a new coroutine again afterwards. So that's a pretty neat thing to know about when we want to check the status of our coroutine to see whether we can either continue with our coroutine or we reach a certain point where we just don't want to use it anymore. This is a great way of checking whether that can be done or not. And finally, we are at the last part that makes coroutines very useful, and that is with the use of their yield function. So to explain what a yield is, this function basically stops the coroutine with whatever it's doing in order to do anything else that the script needs to do, and if we needed to, we will resume the script again to then continue off whatever it was trying to do with this thread without completely getting rid of it. Let me show you what I'm talking about. Let's delete all of this code that we have here and let's create a new thread. So we're going to call this one local loop thread equals coroutine.create function, open parentheses, close parentheses, enter. What we're going to do is make a while true do statement. So let's say while true do. Let's create a for loop. Let's say for I equals 1, 10 do. So this is going to execute 10 times whatever's inside of here. We're going to write a print statement by saying print I. Just simply, it's just going to print whatever the current number is here. And let's also execute this coroutine. So we're going to say coroutine.resume, open parentheses, close parentheses, loop thread. So what this should do is if we run, then we should see all 10 numbers being printed onto the output all at the same time. But what if we wanted to stop execution of this coroutine to do other things afterwards and then resume this coroutine again to continue what it was trying to do before in the state that it was when we told it to pause? This is where yielding comes in, and let me show you what it looks like. So we're going to drop a line after the print statement and we're going to say coroutine.yield, open parentheses, close parentheses. This is pretty much what it's going to look like right here. So what happens is that when we call resume to execute this loop thread coroutine, it's going to start at the first position of the loop. It's going to print 1, and it's going to pause execution of this coroutine wherever it is. And let me show you what that looks like. If we hit run, we should only see 1 being printed because we told it to print 1 and then we told the execution to stop. Now let's see what happens if we add more onto this. Let's drop 2 lines down here and let's write a print statement here saying execution has stopped. And let's drop another line. Here's how we can resume the thread. And you guessed it, we're basically going to write another coroutine.resume and we're going to throw in the loop thread coroutine. Now, what should surprise you is that when we call for the first coroutine and it's going to print the first number here, you might think it's going to do the same thing again for for the print statement by just saying print 1. But here's what's actually going to happen. Let's hit run. And what should happen is that it's first going to print 1 because we called execution, so it's going to start at 1 and it's going to print 1 and it's going to pause the coroutine. And then once this is done, it's going to go down here to print execution is stopped, and then we come down here to resume or continue the coroutine of loop thread. It's going to pick right back up where it left off after this coroutine yield was over. It's going to go back to the top and increment 1 to 2, and then it's going to print 2, and then it's going to yield again. So we can just continuously do this by saying execution is stopped, and then it's going to resume the thread again to print 3, and it's just pretty much going to keep doing this. So this is going to happen exactly 4 times. So it's going to print 1, execution is stopped, print 2, execution is stopped, print 3, execution is stopped, and then finally it printed out 4. I will go into more detail with yields, but just for a quick minute, I'm going to introduce one more coroutine function, and that is coroutine.close, which just simply ends the coroutine, and we just won't be able to use it anytime afterwards unless we create another coroutine. So what we can do is that after, let's say, the second execution, let's drop a line down here, and we're going to say coroutine.close, and then inside the parameters, we're going to throw in our loop thread that we created. So pretty much what's going to happen here is that when we close the coroutine, we're not even going to be able to resume these threads because we already closed this loop thread, so it can no longer continue what it was trying to do. So if we hit run, what should happen is that after our second execution, then it pretty much printed out execution has stopped, but then it tried to resume the thread, nothing happened, and then it printed out execution has stopped once again, but also it tried to resume the thread once again, but it did not work because our coroutine is already dead because we called close on the coroutine. So that's another coroutine function I want you to know about when you're handling these coroutines. Another thing we can do is return values when we call coroutine.yield. So we can actually put in parameters. So we can actually put in arguments here for when we decide to return something after we pause our coroutine thread. So what this will look like is this is pretty much going to be returned when we call coroutine.resume, because when we call coroutine.resume, that's when we start the thread of whatever's inside of here. And then when we call coroutine.yield, it's going to return whatever arguments we put inside of here back to coroutine.resume. So we can actually wrap this coroutine.resume inside of a variable. So before coroutine.resume, we can say local success equals coroutine.resume loop thread. And what we can decide to put in here is just put in a Boolean here, just say true, basically indicating that this yield has been successful. Now, obviously, this is kind of an arbitrary example, but what I'm trying to get at here is that you can pretty much put in any arguments here and pass it back to coroutine.resume once execution's over into our new variable. So we can drop a line here and then print our variable true. If we hit run, it's first going to print the 1, and then it's going to print our return value, which is true, back into our variable success after we call coroutine.resume, and then we can print that here in the output, which is going to be true. So that's another interesting thing you can do with coroutine.yield is return arguments in case we want to pass in any information from yielding to then do other things with it. We can pass in as many arguments as we want. We can say true, we can say, I don't know, the number 5, we can say a string that's just false or anything like that. And we can do that as long as we fulfill the number of variables that tie into the amount of arguments that we pass back. So this is success. We can separate this with a comma by saying number, and then this is going to be result, or just anything. It can be whatever you want it to be. And we can print all of these out here in the output too, with number and result. Okay, there was a little mistake here. So when we return a yield, it's automatically going to implicitly return true. So what this would look like is it would actually return true, true, 5, false, because the first true is already passed back into this variable success. So what it's actually going to look like is it's going to be success, and then it's going to be whatever results we have after that. So it's pretty much going to look like this. We have our first result here, which is true, so we're just going to call this result 1. And then we have our second result, which is 5. We'll call this result 2. And then finally, results 3, which is false. We can print all these variables out. So result 1, comma, result 2, comma, result 3. So this is pretty much how it's going to look like. Success is going to implicitly be returned to let us know that yielding was successful. And then we have result 1, which is tied to true, result 2, which is tied to 5, and then result 3, which is tied to false. So if we run the script now, we should see all of our arguments being printed inside of the console. So we first have our 1, and then we have result 1, result 2, and then result 3, which is true, 5, false. So it basically works as intended. All right, now you might be sort of confused when we would use coroutines inside of our Roblox games when we're creating them, because so far what we just did with our scripts just looks like a whole bunch of concepts just scrambled on together inside of our script without really doing much. So let me just lay down a couple of ideas of when you would potentially use coroutines during your development. There's a few ideas I can think of off the top of my head. One of them that sticks out to me is a countdown timer. So if you're playing a round-based game, for instance, you want the timer to constantly be decrementing the timer every 1 second, while other things are happening in the round other than just waiting for the timer to be over, like giving the player weapons, making changes to the map, having events happen. There's a whole bunch of things you can do with a round-based system, and you want the timer and you want the countdown timer to be one of them, not the only thing happening. So that's one example. Another one could be a wave-based enemy spawning system, where, like, let's say you're playing a tower defense game. You want the waves to be split up into different chunks throughout the entire match, and you don't want all the zombies to be spawning in continuously at once during the whole game. You want to break them down into waves, and within these waves, you want to wait for all of the enemies to be killed first before moving on to the next wave. That's another example I can think of using coroutines, but the imagination is definitely left to the creator's mind. So there's definitely use cases for them. You just have to know what feels right to you. And I believe in your ability to do that. You might also ask, what's the difference between task.spawn and using coroutines? So if you remember from my task functions video, I basically stated that task.spawn is used to simultaneously run a task alongside a different task. But here's the thing about coroutines. One of the things that makes coroutines special is its use of being able to yield or pause the current thread and do something else in the meantime and resume the thread whenever we need to continue what we left off with that thread, in a way where we have more control over what gets executed before what. So let's go back to our script and let's delete everything that's over here. If we wanted to, let's say, make a coroutine that does stuff, but we also want our first task to do a little bit of stuff before moving on to the second one and then back to the first one, we can do that with coroutines, but we cannot do that with task.spawn. Let me show you what this looks like with task.spawn first. So we're going to say task.spawn, and then we're going to create a new function here. Let's write a while true do statement here, and let's just print some random stuff here with task.spawn, task.wait, 0.01, and then down here we're going to write another while true do with print outside spawn, and then task.wait 0.01. Let's see what this looks like. If we hit run, then we should constantly see task.spawn and outside spawn running at the same time. but we're not going to be able to control doing specific things within one task and then doing specific things within another task and then switching back to the first one in a more strict order. We cannot do that with task.spawn, but we can do that with coroutines. Let me show you what this looks like with coroutines. Let's delete our task.spawn, and let's do this by saying local loop1 equals coroutine.create open parentheses, close parentheses, function, open parentheses, close parentheses, enter. And down here, let's call the loop. Let's say coroutine.resume loop1. And then we're going to have some tasks going on here as well. Let's say for I equals 1, 10, do, print I. So let's put another for loop here by saying for I equals 1, 10, do, and let's print I. And now down here, let's also make a check. Let's say if I equals 4 in this case, then what we're going to do is pause our coroutine by saying coroutine.yield, open parentheses, close parentheses, and then down here, let's resume our coroutine again by just copying this and putting this down here. Now let's run the game and see what happens. The order in which I printed this stuff out is very interesting. Basically what happened here is that I started execution of my coroutine, which I basically started at 1, and then it kept printing the number, and it's constantly checking whether the number reaches 4. So once it reached 4 down here, it basically stopped, and then it went to our outside for loop to print 10 numbers. And then it continued our coroutine after it was over, where it stopped at 4, and then it just kept on repeatedly continuing until it reached the 10th number, and that's where the coroutine ended after we resumed. It ended at 10. So what I'm trying to get at here is you can't have this level of control over what gets executed when you're using task.spawn over coroutines. I really hope this makes sense. In essence, coroutines let you have more control over what gets executed when you're running multiple tasks. It doesn't work the same way with task.spawn because it's basically like two different threads running individually, while with coroutines, you have two different tasks, but they sort of run interchangeably depending on how you handle these coroutines. So that's pretty much going to wrap up coroutines. It is a pretty complicated concept, so if there was something you didn't really understand about coroutines, I would advise you to rewatch this video and also maybe try and watch other YouTubers who also cover the same topic of coroutines. Maybe their explanation will help you into fully understanding how coroutines work, and also just try to apply these inside of your Roblox games. With more practice and more familiarity, and just pretty much understanding how coroutines and multi-thread processing and all of these other concepts put together work, then I think you'll generally have an easier time implementing these in the future if you decide to use them. Because coroutines are basically an indispensable concept that are used quite a lot for script multitasking and general stuff like that. It's very tough, but part of the journey that's fun is just figuring this stuff out, and then once you have figured this stuff out, it feels so rewarding too, that you now know a complicated concept that you didn't previously know about, and that's just what's really fun about it. So I hope your journey serves well for you, and I hope you found this video to be helpful. Join my Discord server, the link is in the description, and I will see you in the next episode. Take care.